Hello everyone. Today we are going to solve the problem sort array 2. So it is a easy difficulty problem. So the question is given an unsorted array of numbers. So sort the array in ascending order. So the sample input 1 is 1532, the ARR. So the ascending order of elements is 1 2 3 5. So the question is straightforward. We need to sort the elements of the given integer array in the ascending order. Same with the input 2 and input 3. So if you directly say the expected complexities, so they give the time can be n log n. So most of the optimized sorting algorithms take n log n. So average the auxiliary space is big of 1. So we need not to take any extra space for this question. So it is asked in the Cisco company. So as per the arrays, we know. Now let us discuss the approach. Approach is quite straightforward. So the approach is directly. We use the it's a single line we are going to use. So we will use the inbuilt method sort method from the arrays class. So if you see there are no nodes, like we need not to use any inbuilt methods or any inbuilt sort method from the arrays explicitly. So we can just use the inbuilt method. But before using the directly the inbuilt method, let us discuss about the inbuilt method sort method from the arrays class in detail about what it is and internally how it works. So this is the function name it is going to be. So it is used to sort any array of any type. There are two types of sort execution methods. So sort method will see the two types, like if the type of is primitive. So it is case 1. In the arrays.sort method, it works in both ways, means two ways. The first way is if the type of array is primitive, then it uses a if the type of array is primitive data type, so the sort method uses a double pivot quicksort. So we already know quicksort takes average time equals to big of n log n, and worst case there are some of the basic details about the inbuilt method before we are going to use directly. So and next the second type, if the type of array is any object, like the wrapper class object types and the string and other object data types array, so then it uses the sorting called we don't hear it mostly because it is a little less known, but the quicksort and the merge sort are the most known as the optimized sorting algorithms. So other than that, it uses tim sort. So you are not expected to hear this in many places, like because it is rare, only used in the Java's implementation. So tim sort is simply merge sort and insertion sort. So the merge sort and insertion sort both are combined logic, and it is called the tim sort. So tim sort in any case, like the best case, average case, worst case, it takes n log n, which is a good news, rather than the above double pivot quick sort, but it takes a big of n space. So if there is no space constraint and the time is very crucial, then we can use the object types rather than the primitive types, and you apply this dot sort method. If we have any space constraint and time is also crucial but not too far, like the worst cases can be a little acceptable, so we use the primitive data types for the arrays and let use of the arrays dot sort. So these are the basics about the arrays dot sort method. So simply, arrays is a class name related to the arrays, and dot sort method in which we need to give the array name, which is ARR. So now if you analyze the arrays dot sort, so sort method, internally it is taking the ARR as a parameter and its type is int. It is a primitive type. So according to the primitive type, which from the 1 and 2 options it is going to be selected, the sorting algorithm. So you can see the first one is selected, which is a double pivot quick sort. This algorithm is going to be selected by this line to sort the ARR elements. So about a n log n time. So if you run and see the program, sample test case is passed, and coming to the hidden test case, they are also passed. So we can see test cases are passed. So expected error n log n. So we can see the average time is likely n log n. So okay, and it takes big of one space. As we know, no extra space. In place sorting is done. So auxiliary space is also big of 1. So our complexity constraint are also solved or satisfied. So this single line of program is used to solve this program, considering there are no nodes or any conditions not to use. But before using, just go through this small theory about the method and how it works internally. What are the algorithms it uses. So the program link is given in the description. Kindly go and practice the problem. Thank you for watching.